Hi everyone. Today we're going to be completing some quick notes on the area of non-right triangles. Let's start with the right triangle. So given triangle ABC below, where angle C is a right angle, and side length AC measures B units, and BC measures A units, let's write an equation for the area A of the triangle. Okay, so let's go ahead and label this triangle here. I know that angle C is a right angle, so this is really helpful because this leg here of this right triangle is also the height of the triangle, so B. We know that the area is equal to 1/2 base times the height. So in this case, the base is going to be side length BC, which measures A units. And then the height is going to be the other side length AC, which measures B units. So we have 1/2 AB. Okay? And this is going to tell us the area of this right triangle. Suppose then this triangle is not a right triangle. How can we find the area? Well, we need the height because we already know that the area is going to be 1/2 base times height. So if we drop a perpendicular, find that altitude or that height, well, then the area can be represented as 1/2 A, the base, times the height, H. Okay? Well, we could write this not in terms of the height. I noticed that we have some right triangles here. So just like in our law of cosines notes, we can set up a trig equation. We've got these right triangles, so we can do some right triangle trig, so katoa. Let's look at angle C right here. I noticed that we have the height and we have the hypotenuse, the opposite side of angle C and the hypotenuse. So this tells me opposite and hypotenuse. I can set up a sine equation with respect to angle C. So the sine of C is equal to the opposite side length, h, over the hypotenuse, b. And then solving for h here, we can multiply both sides by b. We get b sine of c is equal to the height h. So then substituting back in this equivalent expression for h in our area equation, we get 1/2 a and then times h. But instead of h, we're going to substitute in b sine of c. And this is going to be our area formula for any non-right triangle here. And notice that this equation here doesn't have any h's in it. We substituted it in this quantity, this expression, in for h. So we don't actually need the height of the triangle as long as we have two sides, A and B, and then that side, that angle in between those two sides, we can find the area of that triangle, which is really handy because sometimes we don't have the height. Okay? So here's the formula for the area of non-right triangles. Note that the height of the triangle is not needed to find the area. We only need two sides and the included angle or side angle side. Okay? So we have area is equal to 1/2 AB sine C. So for example, if I have A, B, and C like this, we can find the area of the triangle. Okay, so any two side lengths and the angle in between. Okay, so let's get some practice. Let's find the area of each triangle. We're going to round all answers to the nearest thousandth. Okay, so that's 3 decimal places. So this here, a triangle ABC, I noticed that we have side angle side, so we're ready to find the area. We're going to do area is equal to 1/2. So our formula says AB sine of C. So we have A is going to be 15.8. B is going to be 13. And then we have sine of C, which measures 29 degrees. From here, let's go ahead and plug it into our calculator. So in your Inspire, go ahead and open up a new doc, calculator. I'm going to do 1/2. So Control divide gives us our 1/2 times A, which is 15.8. And then times our 13, and then times the sine of 29 degrees. And in fact, you can just type it into your calculator exactly as you see it like this. We're going to hit enter. It's going to give us a decimal approximation. As always, double check that you're in degrees mode. Okay? Because 29 is represented in degrees, we need to calculate in terms of degrees. So rounding to the thousandths, we have 49.790. So the area is equal to 49.790, and then our units, square meters. Okay. All right, number 2. In STR, the measure of angle S is 52, R is 8 meters, and T is 13 meters. Let's go ahead and draw the triangle, STR. And then we know that angle S is 52 degrees. Side length R, which is across from angle R, is 8 meters. And side length T, which is across from angle T, is 13 meters. So we have side angle side. We're ready to use our formula, our area formula. So area is equal to 1/2. We're going to have side length T times side length R, sine of side length of angle S. So we have angle area, I should say, is equal to 1/2. T is 13. R is 8. And then we have sine of our angle 52. Back to our calculator. We have 1/2. I'm going to hit Control Divide. So 1/2, 13 times 8. And then sine of 52. I hit enter. It's going to give us an exact answer, so a decimal approximation. Control enter. And we have 40.977 rounding. So our area, 40.977. Our units here are in meters, so square meters is area. Okay. Got one more for us today. The sides of the solar panel shown measure 50 feet by 30 feet by 30 feet. This is a triangular solar panel on the roof of a house, it appears. If each square foot of solar panel generates approximately 200 watts of electricity per hour, how many total watts of electricity are generated by the entire panel per hour? Okay, so I'm going to just redraw this triangle just so that it's a little bit easier for us to see. So we have 30 over here, we have 30 over here, and then we have 50 on the bottom. Okay, that's all we know. I'm going to go ahead and label this ABC as well. Okay, so in order to find the area here, remember we need side angle side. We don't have any of the angles, so in order to find the angles here, let's go ahead and use the law of cosines. So let's solve for angle A. So the side length across from angle A is 50 feet, so that's going to be that quantity squared by itself. So we have 50 squared is equal to 30 squared plus 30 squared minus 2 times 30 times 30 cosine of angle A. Okay? Well, 50 squared is 2,500. 30 squared is 900. 30 squared is 900. And then we have 2 times 30 times 30 is 1,800. Okay? 900 plus 900 is 1,800. If we subtract that from 2,500, we're left with 700. So we get 700 is equal to negative 1,800 cosine of A. So then the cosine of A must be equal to, dividing out negative 1,800, 700 over negative 1,800. And then taking the inverse cosine of both sides, we have the inverse cosine of negative 700 1,800ths. And yes, you could reduce this. But we're just going to plug it into our calculator as is. Okay? So the inverse cosine, back to our calculator, inverse cosine of, Control Divide, we have 700 over negative 1,800. Gives us an exact answer, so let's go ahead and hit Control Enter. That gives us our angle measure in degrees of 112.885 degrees. So angle A is equal to 112.885 degrees. Now this isn't our answer, this is just the angle A. We're going to use angle A to solve for the area. So this is our 112.885. All right, so for the area, that's equal to 1/2 side angle side. So our two adjacent side lengths are 30s in this case, with the included angle sine of our newly found 112.885. Okay. So let's go ahead and find the area here. So we have 1/2. I'm going to hit Control Divide. 1/2. And then we have times 30 times 30. Then we have sine of, and I'm just going to hit answer. So Control answer. Okay. And yep, that's going to give us our area. I'm going to hit enter. And that gives us an area of 414.578 square feet. Okay. So the area is equal to 414.578 square feet. We're not done yet. This is not our answer. The question is asking if it produces 200 watts of electricity per hour per square foot, how many total watts of electricity are generated? Well, what we have to do is take our square footage, our 414.578, and then multiply it by 200 watts. Okay? And that's going to give us, let's go ahead and multiply that out. So times 200, that's going to give us 82,915.620 rounding. Okay, so we have 82,915.620 watts, our units. Okay, and that's our answer. So in 1 hour, this solar panel is going to produce a whole lot of power, about 82.9 kilowatts of power. Okay. All right, so this has been our notes on the area of non-right triangles. In summary, we need side angle side, two sides with the included angle. We can use this formula here. Notice that we do not need the height of the triangle, which is really nice. All right. If you have questions on this, please send me an email or leave a comment. Otherwise, we're going to see you tomorrow in class. Have a great day, everybody. Goodbye.